simple words, the energy that is received from the sun is referred to as the solar radiation or the insolation. When there is greater insolation, automatically the amount of energy received is also more. Now, when we talk about atmosphere, what are the various processes through which the atmosphere is basically heated or cooled? You all have or must have studied in your classes electromagnetic spectrum. Energy lost by the earth is 23 plus 9 plus 19, which is 51. When there are more land over here, there is going to be more deviation also. Over here, lesser land is here, so that means there is more parallel to the latitudes. Hello aspirants, welcome to PW Only IAS. I am here Harpreet Singh with another very interesting session from the physical geography. This topic basically deals with solar radiation, heat balance and temperature. Students very often find it difficult to understand the concept of heat balance, solar radiation. Let us understand this chapter in detail so that every concept of yours is absolutely clear and you will be confident while appearing in the preliminary as well as the mains examination. Please remember, this topic has been repeatedly asked in your preliminary examination as well as your mains examination. So, please carefully note down all the points which are being taught to you. Along with it, revise it repeatedly so that you have a grasp of the topics that are mentioned in this particular lecture. Let's begin. This is a QR code for my Telegram account. Here you can find the PDFs of the topic which are being studied along with anthropology optional, along with society social justice and general preparation for the civil services. Okay, let's begin with the chapter. Now, something very obviously we very often hear about solar radiation, right? Now, something which we have heard or seen in our classes, even class 6th and 7th, we have seen this. That is why I have created a cute figure for you. This is again handmade. Why I have made this is so that you can understand it from the very basics, right? What is solar radiation? Or very often we call it insolation. What these words are basically saying, what they are is, please understand, the energy received from the sun in the form of short waves. Now the energy which is being received by us, that is basically referred to as the solar radiation or the insolation. Now you have heard this particular word, short wave, and with the terrestrial radiation, that means the radiation which is given out by the earth, you will hear the word long wave. We will study this concept later on so that what it basically means. But meanwhile, in simple words, the energy that is received from the sun is referred to as the solar radiation or the insolation. Now please remember, now if you see the size of the sun, it is so huge. It is basically emitting the energy from all the direction. It is going in all the directions. But if you see the size of the earth, you will see it is just receiving very small part of the total energy of the sun. To be more precise, earth receives only half billionth of the sun's total energy. So we already know that the size of the sun is so small when you compare it, the size of the earth is so small when you compare it with the sun. So that is why the amount of energy also that is received is a minuscule amount if you compare it to the total energy that is emitted by the sun. Now, having understood what is solar radiation, there is one more very important concept, solar constant. Now this particular topic which I'm going to deal in the next slide has been asked repeatedly in the preliminary examination also earlier on and in the PCS examinations also it is very often asked. Now I'll request you to quickly write what is mentioned on the board so that you make the note of it in your A4 sheets, right? Okay, you can pause the video if you want. Okay, let's move ahead. Next concept, if you want to understand the concept of solar radiation, is the concept of solar constant. Now why this is important is, this can be asked as one-liner in your preliminary examination, right? Now, see, let's understand this concept. The amount of solar radiation received on a unit area of the surface facing the sun at an average distance between sun and the earth. So if we take a unit area, the amount of energy that is received in that particular area is referred to as a solar constant. Now it is basically, the figure is 2 calories per centimeter square per minute. 2 calories per centimeter square per minute. Now this calories per centimeter square is also referred to as Lange. So it can also be mentioned as 2 Lange per minute. This has been asked repeatedly in the PCS examinations of various state services. Also, it has been asked in the preliminary examination as one of the statements. So you should be very clear with it. What does it mean? The amount of solar radiation, you know what solar radiation is? That is received on a unit area of a surface facing the sun with an average distance is 150 million kilometers. So with an average distance between the sun and the earth, this is known as the solar constant. Clear? Now, having understood this, we have understood what is solar radiation or insolation. We have understood what is solar constant. Please write this down quickly. You can pause the video and then possibly write it down, right? Okay, having studied this, let us move ahead. Very important factors, that what are the factors that are basically affecting the distribution of insolation? Now, you know that very well, Earth has a tilted axis. That is why if you see, I have tilted it in this manner, right? Now, let us see this basic understanding. During the months of summer time, when we basically see, or let us say when the sun is basically directly facing, let us say, the Tropic of Cancer. Let us assume the sun is directly facing the Tropic of Cancer. In that particular case, do you realize that this particular region will be having more amount of sunlight in comparison to the lower latitudes? Let us assume that sun is over here. Let us see, sun is over here. Now, supposingly there are direct rays from the sun that are coming. For Tropic of Cancer, right? Now, if you realize this, because it is tilted, this region is experiencing, let us say, longer duration of days also, then also a larger amount of insolation also. So that means the tilted axis of the Earth are actually impacting the amount of insolation that is being received on a particular surface of the Earth. Now, if you see this region, this will obviously, when it is directly over the Tropic of Cancer, obviously you know this very well, that there is going to be, by default, greater insolation over here. When there is greater insolation, automatically the amount of energy received is also more. So this is the basic representation which you should be very well aware of. Clear? Okay. Now, please copy it down. Just to explain, we will be doing this diagram later on also. This 0 degree is equator, 23.5 degree north is a Tropic of Cancer, 66.5 degrees Arctic Circle, 23.5 is basically Tropic of Capricorn, and 66.5 degree is the Antarctic Circle. At the top you have over here the North Pole, and over here you have the South Pole. This is a basic understanding that should be clear with you. Clear? Okay. Let's move ahead with the distance from the distance from the sun. Now, if you see, this is the sun. Let us see the condition at the time of July. Now, if you realize that in the month of July, the distance is 152 million kilometers. Clear? And in the month of January, the distance is 147 million kilometers. It is because of the orbit that the Earth has. Now, do you understand something very clearly? That this is the longest distance between the sun and the Earth. This is basically known by a word aphelion. A-P-H-E-L-I-O-N. This particular distance, which is the longest distance at any particular point of time, 152 million kilometers, this is known as aphelion. Whereas the shortest duration is in the month of January, which is 147 million kilometers, which is known as perihelion. That is why on an average, because farthest is 152 and the nearest is 147 million, that is why we take an average of 150 million kilometers as the average distance between the sun and the Earth. Now, please understand. Do you analyze a very interesting fact here? During the time of July, you know that very well that it is summers in the northern hemisphere, right? Now, during this time of summers in the northern hemisphere, the Earth is farthest. Had the Earth been closest during that time, the summers would have been very severe in the northern hemisphere. That is why, again, this is how nature is. Because it is farthest in the month of July, which is basically summers in the northern hemisphere, the summers are not very severe. They are relatively milder. Had that been in the case where July would have been, let us say, a condition which would have been perihelion, in that particular case, the summers would have been so bad, so hot, that possibly it would have basically impacted the survival of the human beings also. Why I'm mentioning about Northern Hemisphere in particular? Because Northern Hemisphere is the one which basically comprises a majority of the land surface lies in the Northern Hemisphere. And so does the human habitation also. That is why this is how balance of things basically happen. Now, January again is, you would see that this is representing perihelion, which is 147 million kilometers, which is these two things. Now, how does these two things basically impact? Now, see, distance from the sea. If now I ask you, there is more insolation during the time of January or during the time of July, 99.9% students are going to mark it wrong. There is more insolation with respect to what is received on the earth in the month of January than in the month of July. Why? Because the distance between the earth and the sun is less, that is 147 million, than in comparison to 152 million in the month of July. So if somebody asks you, because you are staying in the Northern Hemisphere, you possibly assume because it is summers in the Northern Hemisphere, so possibly yes, in the summer more insolation would be received on the complete earth. No. Because the distance is less in the month of January, which is 147 million kilometers, that is where the overall insolation that is received, that means the incoming solar radiation received on this earth, is more in the month of January. So can I say more insolation in January than July due to the distance. So this should be very clear to everybody. Many people get it wrong just for a mere reason that you presume that you are in the Northern Hemisphere and it is summers during that time, so possibly there is going to be more insolation. No, it is overall the distance that is mattering here. This has been asked as one of the statements in the preliminary examination. Clear? Okay, let's move ahead. Let's see the length of the day. Now, if you realize that if the length of the day is longer, obviously if there is summers during a particular time, summers will have a longer duration of the day, so there is more insolation being received. So we can simply say longer the length of the day, now this is referring to a particular region. I'm not talking about complete earth, particular region, right? At a particular region. Now that particular region can be any part, right? Particular region. So that is more insolation, obviously. Keeping other conditions constant, right? Keeping other conditions constant. Other conditions or other factors constant. Clear? Okay. Please understand this very, very clearly. Clear? You can note this down very well. Quickly note it down. Now see this very well. When I'm talking about next point is the effect of the atmosphere. Now you know that very well that atmosphere itself impacts the amount of insolation that is reaching the, let us say, the surface or the land. Why? Because let us say there is a lot of cloud cover. So the cloud covers is one of the means which is basically reflecting the insolation back into the space. This we will be studying in the heat budget also topic, where we see how much the amount of insolation that is coming and how much is basically observed, how much is reflected, how much is scattered. We'll be studying in that. But the effect of atmosphere is that whatever disturbances in the form of, let us say, clouds or all these things are present there, they basically impact the insolation that is reaching the surface. Let's see. You can say cloud cover, dust particles, etc. in the atmosphere impact the insolation reaching the surface, right? Clear? So that is going to impact the surface. Obviously, clouds also reflect dust particles and other things also, basically reflecting it back. So now we will be studying this in the topic of heat budget in detail. Clear? So this is what we have studied with respect to the factors that are impacting the distribution of insolation. Clear? Let's move ahead. Heating and cooling of atmosphere. Now, very important thing that happens is when we're talking with respect to the topic of climatology. Now, when we talk about atmosphere, what are the various processes through which the atmosphere is basically heated or cooled? Now, please note this very carefully, that there are four mechanisms that I have mentioned here, or four ways, or four concepts also you can say. These are mentioned in your NCERT also, and I have explained them using the diagram. So make sure that you use the diagrams when you are writing your answers also, right? Now see. First is conduction, second is convection, third is advection, and fourth is radiation. Many people would have studied conduction, convection, and radiation in their physics chapters also, right? Very often in class 6, 7th, 8th also you read it. Advection, sometimes you might have read, sometimes you may not, but this is mentioned in your NCERTs also. So we're going to explain this. Now let's understand one by one what are the ways in which heating and cooling of the atmosphere possibly takes place. See. I am taking right now one concept individually, keeping other factors constant. Please remember that very well. When I talk about conduction, the basic thing that you have already studied about conduction is that any body, any particular thing that is heated or cooled, whatever be the scenario, let us take a body that is heated. Now, for the conduction process to take place, that body needs to be in contact with somebody else, something else. Conduction works through the process or mechanism of contact. Let us assume this. Supposingly, this is a hand, which is right now, because I had placed in front of a heater, it is heated. Let us say the temperature of this particular hand increases. Now, let us say this hand, because of the weather or climatic condition, is very cold, and I bring it here and join my hands. So you will realize that the heat from this particular hand is going to this particular hand, and that is because of the contact. This is known as conduction, conduct. Clear? Now see here, similarly what happens is, supposing that this is a land surface, right? This is a land surface which I have drawn here. Now you know that very well that air is everywhere, right? Air is everywhere. Obviously the density of air is greater when you come closer to the ground, and the density keeps on decreasing. That is fine. But do you realize, supposingly this particular land surface is, let us say, hot, little bit, relatively hot. The molecules that are present here, the air molecules, which are in contact with the surface will also get heated because they are in contact. Let us assume this is the surface, the air molecules are present here, they are in contact with this particular surface, they will get heated, so they will warm. Then these, let us assume these particular ones are heated because of the contact, right? Now they will also give certain energy to heat to these also molecules that are present. Yes or no? By contact only. Now, what do you understand by this? Conduction mechanism is very well effective in the case closer to the ground, because as you move higher, there is more dissipation of energy, and the impact or the effect of conduction will not be so effective. So that is why conduction mechanism in here particular case works well for the air that is present close to the ground surface or the land surface. This is a way in which the atmosphere is heated. So that means heating of the atmosphere in the lower layers is through very important means through the process of conduction. Now, having understood this concept, let us read it also and understand. Why I have written this is so that what I've explained you right now, that will go into your minds, but also the content is here that will consolidate the things. Now see, the earth is heated by insolation. You know that very well. Because of the incoming solar radiation, this particular surface of the land is heated. Now, while the air in contact with the land gets heated slowly. Now you see this air or the air molecules that are present in contact with the land are also getting heated slowly, and the upper layers in contact with the lower layer also gets heated. That means when this particular layer, which is the lowest layer, is getting heated because it is in contact with the land, the upper layer is this upper layer is in contact with this layer, so it is also getting heated. The lower layer is getting heated because it is in contact with the land surface. The upper layer is in contact with this lower layer, so it is also getting heated. But you know that there will be lesser amount of energy being transferred because energy is dissipated, right? So this process is known as conduction. The flow of energy is from warmer body to a cooler body. Understand this very well. This is a basic understanding also. The flow of energy is from a body which is warmer to a body which is cooler to balance it. Clear? So this is the process of conduction. Now this process is relevant majorly in the lower layers of the atmosphere, not in the upper layers, obviously, because we know that other mechanisms are working, and one has to be the particles or the molecules have to be in contact for the process of conduction to take place. Clear? Effective mechanism. If in the question, in the exam, it is asked that, let us say a tricky question, one of the statements that conduction process is relevant only in the lower layers. So that statement is not wrong, that is correct. Clear? That is what the NCERT also basically mentions, so that is really marked correct. So keep this in mind very categorically. Clear? We have done with conduction. Now let us move to the concept of convection. Now you know that very well. When you were in class 6th or 7th, you were taught the concept of convection, where let us say you heat a pan which is filled with water, you heat from below, and there are convection currents that are established, right? Similar phenomena basically happens in the atmosphere also. Now what happens is, see, in this process, when the layer is heated, now please understand, when a lower layer is heated, it might rise up, rise vertically. This vertical rise is basically, and that vertical rise leads to the spread of energy also, transmission of energy. So this rising vertically and then dissipation of spreading of energy or heat is basically referred to as the formation of convective currents, and this phenomena is known as convection. Now let us see this. The air in contact with the earth rises vertically. Now you see, supposing the earth is heated tremendously. Now please see, conduction was a process through which, let us say, the lower layer is heated and it is basically spread, giving its heat to the upper layer also. Now there is no vertical movement that is being talked about there, no. Here, when the lower layer is heated, it rises up, right? It rises vertically on heating in the form of current. Now this is like a current that is rising, right? And while this process is going on in the vertical manner, it is giving energy to the nearby layers also. Why is it rising? The reason is because the layer which is warm has got lighter. The lighter ones are going to rise. The cooler ones will take its place. Now see here, let us assume this. When this air is, because it is heated, it is lighter. Now lighter one will rise, so it is rising up. On the other hand, there will be cooler layer, which a cooler will take its place. You have seen this mechanism basically in the land and sea breezes also, which we will be doing in the next chapter. You must have studied also. The similar mechanism happens there also. Clear? So this is basically known as convection. Now please remember this very carefully. A very particular, very important line is mentioned in the NCERT. And this has been asked in the preliminary examination also. When I talk about convective currents, in the previous chapter you had heard, or I had mentioned very categorically, that the weather phenomena and the climatic phenomena are basically confined to the troposphere layer, right? Similarly, over here also, the convective transfer of energy is confined only to the troposphere. This should be kept in mind. There can be questions which they can alter it, like they can mention, it is present in the mesosphere, so and so, what such types of things can be mentioned. So you need to understand this statement is mentioned. Now many will say, no sir, there have been certain research studies which mention about these things, new discoveries. Please remember, the NCERT is a core where the UPSC basically considers it as correct. So this is what you have to basically abide by. Clear? Okay, please note it down. Pause the video and note it down. Okay, now next. Now we have covered two things. First, without any vertical movement, supposing that air is being heated, the air molecules are being heated, that is conduction. And let us say because of heat, there can be rise of currents also, a vertical rise, that is convection. Now do you realize, along with them, there can be there is horizontal movement of air. See, the difference between air and wind is, air is still, wind is moving air. Understood? Horizontal movement basically, please understand, air is still. Horizontal movement of air will be known as wind. Clear? Now over here, please understand, advection basically covers this aspect. Do you realize there is a great possibility also sometimes when you see during the just before the during the time when the summers are on its peak in India and the northern regions and the northern plains, we have very dry, dusty, hot winds that blow, which are known as lu, right? Now that is basically what a horizontal movement. That is horizontal movement, and that horizontal movement is basically impacting what? The atmosphere, na? The lower layers in the troposphere only, but it is impacting. Isn't that transmitting energy from one region to another? It is based on the horizontal movement. So advection basically refers to the horizontal movement that has taken place. So transfer of air through the horizontal movement of air, or transfer of air, and plus you can add plus the energy or the heat. This can also be added. Yes, na? Obviously there is energy or heat is also being transferred. Now this process is known as advection. Now please remember, there are certain things that are being mentioned here. In the middle latitudes, most of the diurnal variation in weather is caused by advection. There are various regions, particularly in the middle latitude, where whatever diurnal means day and night variation that happens, there is a great impact of the advection, that is the wind movement that is taking place. So that is why they also occupy a very important position with respect to heating or modifying the temperature or the energy changes that take place in the lower atmosphere in particular. Now, Lu is again an example of the advection process, right? You know that it creates a lot of dry conditions, people suffer a lot of heat strokes because of Lu, right? Because it is dry, dusty, and there is horizontal movement of the air. Clear? This is known as advection. Now we have done three processes. First is the conduction, second is the convection, third is the advection. Now comes the radiation. Now please understand this very well. When I talk about radiation, there are two things we should understand. First, when I began with the chapter, I had very categorically mentioned that incoming solar radiation, I mentioned the word radiation, incoming solar radiation, and I mentioned the word short wave. Clear? Now that is one form of radiation. That means when the radiation from the sun are basically coming, they are also what? They are also without any contact, right? There is no contact here. Without any contact, they are heating the atmosphere. Firstly, that is what is a characteristic feature of radiation, without any contact. On the other hand, when the radiation is being observed by the land surface, then there are emissions of radiation from the Earth's surface also back into the atmosphere, which we will be doing in the concept of heat budget after a few minutes. So there are two things that are happening. One is incoming solar radiation. Other is terrestrial radiation. Terrestrial radiation means something that is given back by the Earth into the atmosphere, because Earth has to maintain a balance. That is what heat budget is, which we will be studying. See, if continuously heat energy keeps on coming from the sun, and that keeps on absorbing, obviously the temperature will increase so much that it will create a lot of problems. That is, the balance will be not maintained. So that is why that energy has to be given out. Yes or no? For example, you take your bodies. When you urinate, when you go to the toilet, you realize that along with the urine, energy is also basically dissipated, given out. These are also ways. When you sweat, there is evaporation taking place that cools your body. So body also has a mechanism to maintain its temperature. Similarly, Earth also has a balancing act through which it maintains its temperature. That is what is known as a heat budget also. Because when I talk about temperature, it is also a form of energy. Now see here, the incoming solar radiation heats the surface because it is without contact. That is what is a characteristic feature of radiation. So Earth receives insolation from the sun in the form of short waves, which is known as incoming solar radiation. Now, we will be studying all these things, don't worry. While the Earth, after being heated, becomes a radiating body, because it is heated now, any heated body gives radiations, right? Now, it radiates out to the atmosphere in the long wave form, which is known as terrestrial radiation. So terrestrial radiation refers to the radiation that is dissipated from the Earth because it was heated. Clear? Now comes a very interesting thing that you should all note it very clearly. See here. You all have or must have studied in your classes electromagnetic spectrum, right? I will not go into the physics or the component, though you have to study for your general science as a part of the civil services. But I'm just mentioning one thing. See this. Remember this as GXU Wimmer. GXU Wimmer. Now, what does this basically mean? See here, let us see this one by one. G basically refers to gamma rays. X basically refers to X-rays. U basically refers to the ultraviolet or the UV rays that you talk about. V basically refers to the visible light, the ones which you can basically see, right? I refers to infrared. M basically refers to microwave. R basically refers to the radio waves. Now you should understand one thing very clearly. As you move to the left side, clear? How you'll remember? GXU Wimmer. This is something that I learned when I was in class 10th. From that time, I don't forget this because it is by heart. I learned in that manner when I was in class 10. So GXU Wimmer. Now please understand one thing. You should understand that these particular side, as you move from this side to this side, there are a lot of variations that happen. First, let me understand this. See here. As you, let us say, if you are in this position, let us say gamma and let us say radio waves, I'm just mentioning here. This is a region. These are those waves or forms of energy which are high in energy, right? High energy. These are relatively low energy, right? Along with it, these have high frequency. Frequency of waves are very high. These have low frequency. Frequency has an inverse relationship with the wavelength. That is why remember that these particular waves have low wavelength. And that is why these are known as short waves. These are basically referred to as long wavelength. Long wavelength. So these are referred to as the long waves. Now please understand that means as you move towards, let us say if you move from gamma rays till this position, the frequency will keep on decreasing, the energy will keep on decreasing, the wavelength will keep on increasing. Clear? Now remember, when I mentioned over here that the sun basically emits short waves, like incoming solar radiation is in the form of short waves. See here, short waves, incoming solar radiation. That is why do you hear that when I talk about incoming solar radiation, we very often mention about UV rays. Now please remember this. The incoming solar radiation has all of them. The incoming solar radiation has all of them. But the amount which if I see UV rays is the maximum. So incoming solar radiation that means visible light is also there. Incoming solar radiation has all of them. But major component is UV. Now tell me just one thing, when I talk about UV basically lies in the bracket of high frequency, relatively higher energy, and short wavelength. That means it is a short wave. What is this? Isn't this a short wave? If you compare relatively, these are higher energy ones. Na? So before the visible light, these are higher energy. After the visible light, these are relatively lower energy. Visible light basically forms a middle position, right? Short waves. That is why the incoming solar radiation is talked or spoken in the form of short waves. Now, when Earth has got heated, it will emit radiations. Now, please remember one thing. Out of the radiation which is emitting, the major radiation is which one? The infrared. Now, infrared, you should understand on the left side of the visible light are the high energy, high frequency and low wavelength. On the right side are relatively what? Low energy, low frequency and higher wavelength. So, infrared are the major component of terrestrial radiation. Many will say, sir, does microwave and radio waves are on some amount present? Yes, very minuscule amount, yes, but major is infrared. So, major component of terrestrial radiation is infrared. Now, what I have taught you over here is the most important thing in this chapter, which is not explained properly in the NCERT. If you know this, you can solve a lot of questions which have been asked. Now you will say, sir, now this infrared lies in the bracket because it is on the right side. It is basically lower frequency, lower energy, long wavelength. Can I call it a long wave? See here. So while the Earth, after being heated, becomes a radiating body, it radiates heat to the atmosphere in the form of long waves. So these are basically what? The infrared rays which are being given. What are these? These are majorly UV rays that are coming. So after heating, Earth radiates the infrared. That is why it is known as the long waves. Clear, everybody? This should be very clear in your mind. If this concept is clear, most of the concepts will be clear. Clear? Okay. Now let's come to the concept of heat budget of the Earth and the atmosphere. When I talk about heat budget, please understand, this basically refers to the balance between the incoming solar radiation and the terrestrial radiation. See here. When I talk about heat budget, it refers to the balance between incoming solar radiation. Now, just tell me one thing. When I say incoming solar radiation, what do I mean? I mean insolation. And what do I mean? Short wave. Clear? So, it refers to the balance between the incoming solar radiation and the outgoing is what? The terrestrial radiation. Terrestrial radiation. Now, terrestrial radiation is in the form of, you know that very well, it is long waves. Now, why this is done? This is basically done so that there is balance of energy. Energy over here also means temperature. If excessive amount of energy is basically trapped inside, what will happen? It will lead to disturbances with respect to the life, with respect to the climatic changes that might basically aggravate. So it is basically a mechanism through which basically things basically happen, and the homeostasis in a way is basically maintained. Clear? Now, please understand, this topic again is considered the most difficult topic by the aspirants because they never understand how this heat balance basically works. This has been asked in the mains examination also, and repeatedly it is asked in the preliminary examination also. Now see this very carefully, and for PCS exams, if you ask me, every single year a question comes on this. Any PCS across the country. Having understood what is heat budget, you can quickly note it down. It is basically refers to the balance between the incoming solar radiation and the outgoing terrestrial radiation. Now see here. Now the problem that many people face is it has a lot of numbers that are mentioned here. Here also and here also, and possibly this makes it difficult to remember and possibly understand because we have not studied mathematics and all. But this is not mathematics, this is basic 1, 2, 3 that you basically do. Once you understand this, you will not face any problem. But way I am teaching you, you need to follow that mechanism very, very categorically. This is one of the most important topic that you can come across. Clear? Now see. Let us assume that when I talk about heat budget, I will be basically talking about the balancing, what is incoming and what is outgoing. Incoming, that means incoming shortwave solar radiation. So what all is coming, I will be seeing how it is impacting and what is happening to it. And then I'll be talking about what is outgoing long wave radiation, which I'll be talking about that. Yes or no? Yes. So let us take one by one. Let me take that I'm taking now, right now, the incoming solar radiation or the radiations that are coming from the sun. Now see, if I take a specific number and all, it will become difficult. So let us take one thing. Let us take the complete solar radiation which is reaching the earth as 100%. Or you can take 100 units, right? 100 units or 100%, whatever. Take it as one, doesn't matter. 100% or 100 units. Let us take this total insolation that is basically coming on the earth, let us say even the atmosphere and all, is basically 100% or 100 units. Now, when it will be when the solar radiation will come, it will encounter the atmosphere. Now, there will be a lot of things that will happen. Some will be, let us say, radiated back, some scattered, and a lot of phenomena will take place. And out of it, some part will reach the surface of the earth. Not all. This is what is being studied here. Let us see. But let's imagine this 100 basically refers to the total insolation, right? The way I'm teaching you, understand it that way, you will not face any problem. Now, when I say, let us say the total insolation is coming, this insolation is coming here. Now, what happens is, out of the 100 units, let us say 100 marks you have, 100 units or 100%, whatever, out of these 100, certain amount of units or radiation will be reflected back. Now, before you do, please understand this diagram also. Let me make it very clear. This green basically refers to the Earth's surface, right? This particular point, this line is referring to the Earth's surface. This particular part is referring to the atmosphere. More precisely the troposphere which we are talking about, right? This is referring to the outer space, even mesosphere, even exosphere and all those things, which is empty space where the atmosphere merges with the outer space. This is more important for us. This is the troposphere because most of the climatic phenomena take place in the troposphere. So though we are mentioning atmosphere, it is basically talking about mainly the troposphere. Obviously, other layers are being considered. Now see, as the total radiation is coming, out of the total radiation, 27 units is being sent back. That means reflected by the clouds. Where? Back to the outer space. That is why I have written minus here. Clear? That means 27 units are sent back into the outer space. So, gone. Secondly, now please understand, out of the radiation that is 100 units, 27 is gone. No need to worry about it, it's gone. Out of the 27, out of this 100, some radiation which reaches the surface, the earth also reflects it. How? You will realize that sometimes you would have studied that, let us say the snow cover is there. Sometimes the snow cover also reflects the radiation back. So out of the 100 units, 27 units have been reflected back by the cloud and 2 units have been reflected from the surface of the earth. That is why please remember, presence of cloud cover, that is what I had mentioned in the insolation, the factors affecting that. The greater the amount of cloud cover, which basically impacts the insolation that is reaching the ground surface or the surface of the earth. So 27 is gone back, 2 units are basically sent back by the earth. So because it is sent back to the outer space, it is also minus 2. So minus 27 minus 2, that means out of 100 units, you have already lost 29 units, which are sent back to the outer space. Now, you will realize that scattering of lights also, because of the dust particles and all that are present, because of that scattering also, 6 units will be again, because of that scattering, sent back to the outer space. So that means, what do you see over here? Out of the total 100 units, 27 units outer space by the cloud, 2 by the earth, minus 6, that means 6 units scattered in the space. Now, what is actually reaching the surface? Let us see this. Out of these 100 units, there is certain amount of rays which was scattered, though it is reaching the ground surface. That is why I added plus 17, because the Earth's surface is absorbing that amount of radiation. So plus 17 here. Now these are based on the estimation, so they have simplified this. Though actually you are measuring in the form of energy and all, those are complex units. This is a simplified form. So out of them, 17 units out of the 100 are reaching the ground surface through the scattered radiation which is entering here. Direct radiation, do not assume that cloud, because the cloud cover is between it, is just a representation. Cloud has scattered, but all the other is basically coming to the ground surface. So 34 units are directly where it did not encounter any cloud or straight away it came to the surface, the radiation came. So that was 34 units. So 34 units are reaching the ground surface. Out of 100, you have realized these have gone to outer space, these have been observed by the Earth's surface. Another 14 units are observed by the atmosphere. You realize when the insolation is coming, obviously the insolation will also heat the atmosphere. You had studied the radiation concept where I had told you terrestrial radiation as well as the insolation, which is also heating the atmosphere. So 14 units will be observed by the atmosphere itself. This is basically the phenomena which you study with respect to the incoming short wave or solar radiation. Now, see here, the same thing that I've explained here is mentioned over here. See now, total insolation is 100% or 100 units. Reflection by cloud is 27 units or 27%, whatever you want. Reflection by earth is 2% or 2 units. Scattered to space is 6 units. That means 35 units are lost, are gone. Out of the 100 units, how much is remaining now? 100. So that means, can I say this, the remaining is 100 minus 35. 100 minus 35, what is remaining? 65 units. So 65 units are the one which are remaining because the other 35 are already gone to the outer space. Now out of this 65 units, let us see the heat budget of the Earth. Earth is this surface, atmosphere is this surface, this area. Now heat budget of the Earth, what is it, how it is heated? By direct radiation, 34 units, 34. By scattered radiation, 17. Total is 51. Total is 51. Now, heat budget of the atmosphere, did you see that over here atmosphere is absorbing what? 14 units. So, absorption by the insolation, 14. So, now see, 15 plus 51 plus 14 is 65. So, this 65 units which was remaining is being distributed in such a way that 51 units are being observed by the Earth and 14 units are being observed by the atmosphere. Now, this is only with respect to the incoming solar radiation. Now, we need to study how it is basically going back. Okay? How it is returning. Now, that returning and coming will be balanced. That is what will be referred to as a heat budget. You have just done what? The incoming solar radiation, where 35 units were sent to the outer space, lost, 65 units were left. Out of the 65 units, you realize that 51 units were observed by the Earth's surface. Some in the form of scattered radiation, that means the 17 units, and 34 units from the direct insolation. Other 14 units were observed by the atmosphere. So this is the incoming solar radiation whole chart that you have done. Now comes the second part of the heat budget, which is the outgoing long wave terrestrial radiation. Now please understand this very well. You need to understand this well. See here. When we study about this radiation which is going, let us again see from the similar manner as we had seen over here, heat budget of Earth and heat budget of atmosphere. Heat budget of Earth. Now you realize this. Everywhere I have mentioned negative here. Why? Because it is being lost. In the previous one, energy was being gained, so I had written plus. Now the energy is being radiated back or sent back, so it is known as minus. So that means 23 units are being, we will study all this later on. Right now, we are not concerned with the atmosphere. This is what the green line is representing, what? The Earth's surface. So heat, when I'm talking about heat budget of Earth, I'm just concerned with respect to the Earth. Now you see 29 units are being lost, 9 units are being lost, and 19 units are being lost. So energy lost from the Earth is 23 plus 9 plus 19, which is 51. Now you will say, sir, from where has 23, 9, 19 come? Better remember, scientists basically calculate them in the form of energy, complete statistical phenomena, and all those things are done. Those are a lot of numbers and all energy units are involved. This is a very simplified form of that complex process, right? That is based on the observation, that how much is observed, how much is reflected by cloud. That is an average that is taken, right? Based on that average, we are studying this. So energy lost by the Earth is 23 plus 9 plus 19, which is 51. Clear? Clear? Now, please understand this. In the previous slide, the amount of energy that was received by Earth was also 51. Now, lost is also 51 over here. Clear? Now, let's see further. Heat budget of atmosphere. Let me take this atmosphere. Out of the 23 units which was radiated out, 6 units were, because it is going out now do you realize that when this is being radiated or given out in the form of, let us say, long wave radiation. Out of the long wave radiation, some will be absorbed by the atmosphere. So it is mentioning that 6 units are being absorbed by the atmosphere. Other 17 units are sent to the outer space to balance the heat. On the other hand, there will be certain turbulence, convective mechanisms, cloud formation and all those taking place. In that particular process also, the 9 units are lost and that are gained by the atmosphere, right? Evaporation will basically lead to losing of the heat from the earth, but addition to the atmosphere. So what can I say? See here. If I talk about the heat budget of the atmosphere, it will be 6 plus 9 plus 19. First of all, see here. 6 plus 9 plus 19, that is 34. But one more thing that we have forgotten to add is, in the previous slide, we had known that the atmosphere already had 14 units. 14 units was already there. Now you realize, we know that these units have come on after the radiation. So we need to add 14 more from this, because 14 units of energy was already there with the atmosphere. So adding 14 units will lead to 6 plus 9 plus 19, that is 34. 34 plus 14 from the previously observed, which gives it to be 48. 48 units. Now see here. Now see here very well. Now see here very well. This energy, which is 48 units, is again being lost to the, later on, to the outer space. So energy lost is 48 units. Now see one thing, 17 units were being lost through this mechanism, and later on the 48 units are again being lost to balance the temperature. So this is 48 units. So 17 units from the radiation. So 48 plus 17 is 65 units. 65 units are being sent out. What was the incoming? 65 units. What is being sent out? 65 units. So this is the balance that is being maintained. Clear? This is known as the heat budget, which we were talking about. Clear? So please note it down very carefully. This is very, very important. Take a screenshot or whatever you want, you're noting down. Pause the video if you want. Okay, let's move ahead. Variation in the net heat budget at the Earth's surface. Now please understand, you need to understand this diagram very well, because some will misinterpret it. Generally, when you see the Earth, let us assume this is the equator, this is the Tropic of Cancer, Capricorn. When I turn it like this is supposedly the 0 degree latitude. This is equator. What does this represent? Let us say this is the equator. I've turned the Earth. This is supposedly representing the North Pole. This is the South Pole. If I rotate it in this way, it will be North Pole will be on the top, but I've turned it like this just to show you. What is it saying is that this basically refers to the latitudes over here, and this is the energy in watts per meter square. The regions between 40 degree north and 40 degree south basically receive an excess amount of insolation. So there is energy surplus regions. You see, this white region is what representing the solar radiation which is coming. The green is basically referring to the terrestrial radiation. So if you realize over here, there is surplus. That means more amount of energy is present in the 40 degree north to 40 degree south region. There is energy surplus. On the other hand, the other regions beyond that is energy deficit. That means there is a lot of terrestrial radiation taking place, their insolation is less. So that is why the difference between the incoming and outgoing radiation is known as the net radiation. This is the graph. So net radiation means the difference between the incoming and the outgoing radiation is basically referred to as the net radiation. So net radiation, if you see, more insolation is in the region of the 40 degree north and south. So that means more energy, that means there is surplus of energy. Beyond that, there is deficit. So that is why this red part is referred to as a surplus, and this regions are referred to as a deficit regions. Clear? Okay. Temperature. Now please understand, when we talk about temperature, you know that very well. Temperature basically talks about the degree of hotness or coldness of any particular thing. Something is hot or something is cold. Clear? Something is hot or something is cold. That is what we talk about temperature. Heat is what? An energy. So see, the interaction of insolation with the atmosphere and the Earth's surface creates heat, which is measured in the form of temperature. So obviously you realize that the insolation that is coming, it creates heat, heating of the atmosphere, heating of the surface of the Earth. Now, it is heating, but how do you measure it? You measure it using the temperature, thermometers or various types of thermometers that are present there. So temperature basically refers to the degree of hotness or coldness of any body, entity or thing. Whether you are measuring the temperature of the land or the atmosphere, you will realize that you are basically measuring the amount of energy that was received that led to the heating or the temperature increase. So while the heat represents the molecular movement of the particles, because let us say when I say heat is given, a particular molecule set of air will be in motion because of the heat. Now, if I want to measure that, the temperature is a measurement of the degree of how cold or hot a particular thing is. This is what you should be understanding first of all. Clear? That is energy, and what is they're referring to the heat and the temperature concept. So please understand this. Note it down quickly. Let's move ahead. Factors controlling temperature distribution. Now please understand this. Let us see this particular diagram only, and we'll write it here only in brief, right? See here. This is one of the easiest topic that you can come across, that what are the factors that are controlling the temperature distribution. Let us see the latitude. Now you just now saw that we know very well that Earth is tilted axis is there and all. Let us see, higher the latitude, higher you go to the latitude, in the latitude, let us say from 0 degree, that is the equator, to let us say 65 degree and a half to 90 degree, you will realize that the rays of the sun are slanting in nature. How? See here. This is supposingly the surface of the Earth. The sun rays that are coming over here, supposing it is direct. Over here it will be slanting. So these are what? Slanting rays in the higher latitudes. Slanting and direct. That is why what do you see? As you move in the higher latitudes, see, keeping other factors constant, please remember, if you're going to mix all of them, then the answer will not come. You have to keep other factors constant in order to study. Later on, when we analyze what a condition of a situation is or a region is, then we take all the factors together. So under normal conditions, what you see, as we move to the higher latitudes, the temperature basically falls. Clear? Altitude. Now you know that very well, that when I'm talking about troposphere particularly, there is a concept of normal lapse rate. Normal lapse rate we had mentioned in the previous chapter also, we will be doing in the next chapter also in detail. Basically refers to the decrease in temperature of 6.5 degrees Celsius per 1000 meters. That means for every kilometer, there is a fall in temperature of 6.5 degrees when you're talking about the troposphere. Now, when you realize that there are huge mountains that are there, let us say if you go to a particular altitude, by default what will happen? Because of the increase in the altitude, the normal lapse rate will work. So as you move higher in the altitude, the temperature will decrease. As one moves higher in the altitude, temperature falls. I am talking with respect to the troposphere, please remember. I had mentioned normal lapse rate, where you realize there is 6.5 degrees per 1000 meters fall in temperature. This should be understood very clearly. Right? Now comes the distance from the sea. Now you know that very well, that if you just imagine that in a country, in India, You have a region, let us say Nanded. Nanded is in Maharashtra and Mumbai is along the coast of Maharashtra. Now you realize that the climatic conditions of Mumbai are almost uniform, very very nice weather conditions, raining also and all. Matlab, it is very calm because why? Because there is a moderating influence of the sea. As you move inside interiors of the earth, you will realize that there is very wide variations because it is far away from the sea. So that means there is a possibility of very high temperatures during the summer months and very cold temperatures during the winter months. Quite possible because of the what the concept we known as continentality. Continentality means far away from the sea. Because the sea has a moderating influence on a particular region which is close by. As you move inside the region, you will realize that the influence decreases and then there is very, very high variations in the with respect to the seasons. There is very high variation that is present. Like summers might be very hot, the winters might be very cold. So you realize that seas have a moderating influence on the nearby regions. Yes? The ones which are far away, are the ones which basically have very, very high variations in the temperature. Ocean currents, if you realize this, that ocean currents, again, if it is a current is warm, it will have a influence. That means it is going to warm the coasts. Let us take the example of during the months of January, the Gulf Stream basically has a warming influence in the Atlantic Ocean. Example. Now, any current which is, let us say, we will be doing this chapter in the oceanography part. What happens is, if a current is warm, it is going to have a warming effect in the regions that are nearby. If it is cold, it is going to have again aspect of, let us say, regions will be impacted from a similar manner because the cold ocean currents obviously have a cold effect on the nearby regions. Clear? So then comes the wind. Now you know that very well. Wind, obviously, whether it is permanent winds, temporary winds, whatever winds we are talking about, they have a very important influence with respect to the temperature. For example, over here we have mentioned right now Lu. Now the Lu, when it comes, it is moving in the regions of the northern plains. You realize that of India, you realize that it basically raises the temperature and the aridity of the region to a very great extent, right? Many people, that is why, suffer from heat strokes. Slopes and the mountain barriers. Now see, you know that very well. If I talk about the Himalayas, if you take the example of Himalayas, if the Himalayas had not been present, possibly the northern plain would have been a frozen region during the winter months. Why? Because the cold winds from the Siberian region are blocked by the Himalayas, the mighty Himalayas. So these barriers being present are basically acting as a climatic divide. Climatic divide, cultural divide, because based on the climate only, civilizations basically modify themselves, right? So this is again a very, very important thing that you should be knowing. You can note it down: latitude, distance from the sea, altitude, ocean currents, winds, slopes, or mountain barriers. Clear? Okay, let's move ahead. Temperature distribution. Now, temperature distribution basically can be seen. Your NCERT does not mention all the aspects, so I'm taking all of them. Vertical, horizontal, and regional. There are three ways through which the temperature distribution can be studied. Note that very well. Through a vertical means, through a horizontal means, and the regional aspect. Now see here. When I talk about vertical, please remember this. In the previous lecture, we have already explained you how the temperature variation across the atmosphere takes place. Like the temperature decreases as you move up in the region of troposphere, in the stratosphere increases, mesosphere decreases, and so on and so forth. You had studied this. But I am not going to talk about all these things. My major concern over here is going to be the troposphere, because I know that very well all the climatic changes that take place are in the troposphere, right? the cloud formation and all. Now people will say stratosphere also has clouds. Yes, it has stratospheric clouds, which are lesser of a concern for us with respect to the climate change here. Troposphere is the one which has all the important climate and weather activities that are taking place. So now, though when I talk about vertical, this is also to be known by you and should be mentioned, because this is the vertical distribution and the changes of the temperature that take place. But over here, we have to talk from the perspective of with respect to troposphere now. With respect to troposphere. Why? Because this is the major region where climatic changes and the weather activities take place. Now see, temperature decreases as we go higher in the altitude. You know that very well. And the rate is also explained in the troposphere. The normal lapse rate has a decrease in 6.5 degrees Celsius per 1000 meter. What is the reason behind it? Please understand, as you move higher, the density of the air keeps on decreasing, first. Second, dust, water vapor, etc. are of minimal value. Please understand that water vapor, and water vapor especially is a very important factor for absorbing the heat, right? For absorbing the heat. As you move higher, the water vapor is almost in a very less or minimal or not even present. That is why in the lower layers it is present, so that is why you realize that temperature is relatively higher. It acts as one of the factor. Next is terrestrial radiation. Now terrestrial radiation is more active in the lower regions. So that is why as you move higher, you will realize that the temperature is going to decrease, and this is the rate that is observed. Now the processes that are involved when we talk about the vertical distribution that is taking place of the temperature, it is conduction, convection and radiation that you've already studied. Along with it, you know that we have not mentioned advection here. Why? Because we're talking about horizontal right now, right? We're talking about horizontal right now. So vertical distribution is conduction, convection and radiation. Clear, everybody? Please note it down. Please note it down. This is basically with respect to the troposphere that takes place. Okay. Now next, horizontal distribution. Please understand, before I do the horizontal distribution, there are certain things that you should know. I'm going to use a map which is present in your NCERTs also. The two maps with respect to the world, with respect to January month and with respect to the July. Before that, you should know, let me show you a map. Do you realize these lines that I have mentioned, drawn? All these lines are mentioning temperature. Like this is 25, minus 25, minus 12.5, 0 degree, 10 degree. All this is complete 10. This is known as isotherm. This is known as isotherm. Isotherm basically refers to lines joining places having equal temperature. All the line which is joining, that means all the regions that are lying on that particular line have the same temperature which is mentioned. So isotherm refers, therm means temperature, iso means the lines joining the places having equal temperature are isotherms. Now see, let us take, this is the month of January I mentioned here. Now there is a question that was asked even in this year's prelims on this particular topic. This particular map which I have drawn in front of you, handmade, question was asked on this. Right now you understand the utility of the chapter which I'm teaching you. See the map here. Let us analyze certain things. This is minus 25 degrees Celsius, right? This is below that is minus 12.5 degrees Celsius. This is 0 degrees Celsius. This is 10 degrees Celsius. Shift is there. Just observe the path, the way it is moving towards the northern side in the Atlantic Ocean. 20 degrees Celsius. This is the thermal equator. Thermal equator means, this means that the the average temperature is maximum over here. That is why it is the equator. Clear? 20 degrees Celsius here again, 10 degree and 0 degree. So these are lines. That means the lines joining equal temperature. That means this is the lines that is isotherms. Quickly have a look here. Clear? Quickly have a look here. Now what do you see out of this? Do you realize there are certain observations that can be made? I would request you, if you are seeing this lecture, possibly you open your NCERT also for seeing this map, possibly because it will take some time for you to draw. Otherwise, you can use your NCERT or pause this video or make this map. If not, now understand it. I would advise you to open your NCERT while you are seeing this particular part. Why? Because you will be understanding while I'm teaching you. There are certain things you can observe. Why in the Atlantic Ocean it is moving northward? Why in the continent wise it is moving southwards? Why do you see there is a lot of curving in the northern hemisphere, but it is almost parallel to the latitudes in the southern hemisphere? Do you see these observations? This is what the question was asked in the preliminary examination. See here. With respect to January, generally the isotherms are parallel to the latitude. So if normally if you see, if there were no continents, almost the isotherms would have been parallel. But it is because of the presence of the land masses in large number in the northern hemisphere that certain variations are being created. See here. Isotherms are parallel in the latitude, but deviation is more pronounced in January than in July. First of all, you will see this. I will show you both the maps. One understanding is because in the month of January, you will realize that there is more deviations that take place of these isotherms than in July. We'll see that. We'll see the reasons also. Deviation is more pronounced in the northern hemisphere because it has more land surface. Now you will say why? Please see that the ability of a land to heat, cool, or for the water to heat or cool or to move also varies. That is why when there is more land, supposing this region is receiving insolation, this region might get heated quickly, but this water surface will, let us say, take time, or let us say the water might be moved, let us say move along with, let us say, some ocean currents and all. That is why when we say the specific heat capacity basically varies with respect to land and the ocean. Now, when there are more land over here, there is going to be more deviation also. Over here, lesser land is here, so that means there is more parallel to the latitudes. Now, see here. Isotherm deviate to the north over the oceans. Now, you see here. In the Atlantic Ocean, why the isotherms are moving upward? Over here, there is Gulf Stream, a warm ocean current, which is moving towards the northern hemisphere. It carries warm water along with it. Along with it, not only the Gulf Stream, but also the North Atlantic Drift. Now, these both of them basically carry warm water upwards. That is why it raises the temperature of the water that is present in these regions. That is why it basically moves upward. Now, let us imagine 0 degree over here because of Gulf Stream has taken a warm temperature from the equatorial region to the this part. It is 0 degree here, so that is why it curves upward. But land mass will be very cold over there, so that is why it has moved down to match. This is a 0 degree. It has moved down because the land gets heated also cool and cools also cool faster rate. But in the land, if you realize, these regions are going to be very cold, so that is why it cannot be straight. 0 degree will be over here, that is why it curves down. So we see North Atlantic and the Gulf Stream that basically leads to the isotherms moving upward, because these currents will basically take the water upward. It will take the warm water upward, increasing the temperature of this region. So the isotherms deviate north over the ocean due to the presence of warm Gulf Stream and the North Atlantic Drift. This is something that you should be aware, and this was the question that was asked also. Clear? Next is, over the land, the temperature decreases sharply and isotherms bend southward. As let us say cross the ocean, as you cross the ocean, immediately it has to bend down because 0 degree will be here, not here. Because Gulf Stream has taken the temperature over here warmer, but over here this is land. This is going to be cold here because it is in the higher latitudes. That is why it has gone down. It moves towards the south in the continental regions, right? Similarly, if you see over here also, and over here it has gone up. Clear? That means the Gulf Stream is diverting the parallel path which would otherwise would have been. Clear? Okay. The effect of ocean is well pronounced in the southern hemisphere, so isotherms are more or less parallel. So you realize in the southern hemisphere there is lesser of land. That is why it is almost parallel. Little bit of land is there, so little bit diversion is there because of the ocean currents. Otherwise, it is more or less parallel in the southern hemisphere. Clear? This is what is explained here. Now comes July. Now, if you see during the July time, the impact that is caused by the Gulf Stream and or is not pronounced, because already this region over here, sun is receiving, let us say, a lot of direct rays over here. So that is why you realize that sun is already receiving a lot of sunlight over here. So you realize the impact of Gulf Stream as such is not so pronounced. That is why if you realize already heat is over here, that means 10 degrees, 20 degrees. So it is almost parallel if you see, almost parallel. That is why, because in the month of January, the northern hemisphere is very cold. So the effect of Gulf Stream is more pronounced. That is why it leads to more of the deviation taking place, otherwise which would have not taken place. That is why in July the isotherms are generally run parallel to the latitudes. Clear? Okay. Now we have done the vertical distribution, horizontal distribution. Let us see the regional distribution. Now see, it is very simple, which you have done in class also. Tropical, this is known as a tropical zone. From 23.5 degree, this is known as Tropic of Cancer, 0 is equator, 23.5 is Tropic of Capricorn. Between these regions, you realize that this receives a maximum insolation, and that is why it is known as tropical. Let me make it very clear that it is not exactly the tropic equator which has a maximum temperature, because close to this regions you will realize will have relatively higher temperature also in insolation, because at the equator the cloud cover is also very high. Clear? That cloud cover is also very high. But leaving that apart, because this is a simple classification, this is known as tropical region. This is known as temperate, more colder region. Polar zone from 65.5 degree to the North Pole and 65 degrees south to the South Pole. So this is known as a polar zone. It is basically more temperature, lesser temperature, or the least temperature there. So this is known as a regional distribution with respect to the temperature which we're talking about. Clear? Okay. Next comes temperature inversion. Now please understand a very simple and the last topic that we are doing here. Normally what you see is, let us take, normally when you move higher, let us say altitude, what will you see? The temperature will decrease. Normally, leave the temperature inversion topic for 2 minutes. Normally when you move higher in the altitude, there is fall in temperature, right? Fall in temperature. I'm talking with respect to troposphere right now. Please understand this very well, right? Fall in temperature. Now this temperature is basically referring to as a normal lapse rate, which is 6.5 degrees Celsius per 1000 meters, right? Why? Because you realize that if supposingly a surface is being heated, the warm air again will rise. The warm air rises, the warm air will start cooling. This is the normal process of the, let us say, the convective activity that takes place. Now, what is a simple instance of understanding is, from this is, can I say, of supposingly there is layer within the troposphere. Let us say this is basically referring to troposphere. Let us see this. Supposingly this is troposphere. Can I say that this region is what? Some temperature is going to be there. As you move ahead, the temperature will be decreasing. So as you move upward from this layer, moving up is basically temperature decrease. Because the upper layers are colder also, so there is an easier mechanism to move up also. Clear? Because the lower layer, let us say, are literally warmer, and as it moves up, the temperature keeps on decreasing. This is the general phenomena. Now, supposingly a scenario happens that there is a layer above certain layers which is of warmer nature. Please understand this. Supposingly if I say there is a condition where a warm layer is existing above a colder layer. Now this warm layer is existing above a colder layer, which will restrict the movement of the air upward also. So in this process you will realize, instead of the temperature decreasing as you move upward, there is instead an increase in temperature for a small time. This inversion that is taking place is referred to as the temperature inversion. Let's see here. Supposingly this is the Earth's surface in white, right? This is the height I'm talking about. Now, supposingly there's a condition where it was extraordinarily cold on the surface of the Earth. Let us say let us say there's a lot of snowfall. That means that this surface is very cold. Possibly the layer which is, let us say, few meters above that is not as cold as the one which is adjoining the layer which is adjoining the earth. Can I say in that particular case, let us assume this, supposingly this particular, let us say this particular are air molecules over here. These are in contact with this white surface, that is the earth surface. Let us say it is very cold snow surface. This particular region will become very cold. Now what happens is, this is much more colder than a layer which is above it. That means we realize that there is a warmer layer lying above a colder layer, something reverse of what we have studied. So if I draw a temperature graph, you will see that there is increase in temperature because of this layer, which is actually inversion. Then after that, the temperature will decrease because it will follow the normal pattern. But over here, there is inversion taking place. That is why you realize sometimes when temperature inversion takes place, which you see in Delhi, there is a warmer layer that is lying above a colder layer. That is why in the winter months it happens. The air is not able to move upward. And that is why whatever the pollution, smog that is trapped in this layer. That is trapped in this layer. And that is why you cannot basically move out of that region, because the pollution is trapped because of the temperature inversion concept. So temperature normally what happens is decrease as you move up. But if there is an inversion, that means there is a warmer layer above a colder layer. It is known as a reverse condition. We also call it a negative lapse rate. Negative normal lapse rate also is called. So this is a simple phenomena. Again, when we go in the further chapters, we will realize that temperature inversion is of various categories, various types. It is associated with even the valleys. It is also associated with frontal activities, also a lot of things. These are simple concepts which is explained, which you should know. In this condition, long winter nights, cloudless clear sky, dry air, snow-covered mountains, snow-covered grounds are helpful in the creation of these temperature inversion conditions. Clear? This is something that you should be aware of. Clear? So this was a chapter. Hopefully you understood it. We have taken a lot of effort to make you understand all these concepts. Please revise it again and again so that you will be able to do really well. God bless you. Take care. We'll be coming with the next chapter. Till Mindval, Jai Hind.